Hello, in this video, I'm going to show to you how to perform a regression analysis in Excel and how to interpret the summary output. So now you can see the average height and weights of American women aged from 30 to 39, and this is the data. So what I'm going to do first is I'm going to plot the graph. This is the illustration scattered. So this is really not a good graph. So I will change the axis. For x-axis is the weight. So the minimum weight is, let's say, 55, and the maximum is 75. Same goes to the y-axis. Y-axis, the minimum height is 115, let's say, and maximum is 165. Okay, now this is the graph. So you can see this is the positive linear relationships with it. This is quite linear. And now what we have to find is the regression line. So from this data, I will find the analysis. Analysis for regression. Okay. For y range, use the high. High is the y range. And for x is the weight. Once you see the labels and the output range at this. Okay, I'm sorry. This is y. Okay. We also want to see the residue. So now this is the summary output. So firstly, you have to find the, oh, I'm sorry. Firstly, I'm going to change this to fewer decimal place, which is 2. 2 should be okay. Okay. Now this is the summary output. So firstly, we have to find the linear regression line. We have to find the beta node and beta line from this equation. Sorry. This is the general equation we have to find, which is y equal to beta naught plus beta 1 x plus e. Beta naught is the intercept, beta 1 is the slope, and e is the residue. So from this graph of data, we know that this is the linear, so it's easy for us to use this equation, y equal to a plus bx1, bx, I'm sorry. So from this, we know that the intercept is negative x7, x7.52, and weight is 3.45. The intercept is a, so now we have the equation y equal to a plus bx, y equal to, we know a is negative 87.52 plus b is 3.45x. So this is also equal to, we know that y-axis is our, this is the height. So height equal to negative 87.452 plus 3.45 x is the weight. So this is generally the equation for regression line. So now for the regression statistic, we know that the value of r square is 0.99. This value is also known as the coefficient of determination. This value is used to measure the quality of fit. So if the value of r square is equal to 1, so it gives the fit, the perfect fit for our regression line. So for this data, we know that the value of r square is 0.99, so which is closer to 1. So it's conclude that our regression line is clearly perfect. Okay, this is for ANOVA. ANOVA is analysis of variance. The analysis of variance, this is the sum square of regression, this is the sum square of residual, and this is sum square of total. How we find the regression? Sum square of regression, we can subtract this and this. 23.62.93 minus 30.23, we get the sum square of regression. Okay, for this r square, how we get this value is from the division of sum square of regression and sum square of total. We will divide this by this. So 2332.70 divide by 2262.93, we get this value 0.99, which is the value of r square. So now this is the residue output. The residue output is to show the difference between the actual data and the predicted data. And we know why we have to know this residue is this show the how far the actual data points are from the predict data points. So this is the actual data point and this is the predict data point, which is the predict height. Okay, I'm sorry. Why? So predict height. So the actual, okay, from first data, the height is 115 and the predict height is 112.58. So this is the residual. So we know that from the distance between predict data and the actual data is 2.42 for first data. So I will show you the scatter for this residual. So now this is the graph for the residual. Okay, I think that's all for me. Thank you.